Hello everyone. So in this video we will talk about the transformation of an independent variable. So what is the meaning of transformation? Transformation actually refers to, we can say that transformation actually refers to modifying a signal. Modify a signal. There are two types of modifications because we have a signal x of t. So one type of modification is changing its independent variable t, which is time. Another one is you alter the characteristics of the signal, like the amplitude or the frequency. So we have a signal x of t, and in this video we will talk about the transformation of an independent variable t. So it is like the transformation with respect to the independent variable which is time t, and in terms of discrete time signals it is n, which is the samples. So the basic goal of the transformation is to modify the signals and to understand the basic properties of signals and also the systems. Like in the next video you will see that based on these transformations we will define the signal, like the even and the odd signal and also the periodic signal. So we will look at a lot of signals in the next videos. So let's start with the first transformation, which is time shift. So let's say you have a signal x of t and you shift this signal in time, which means that you have a signal x of t and you shift this signal by some amount which is t naught. It simply means that we move the signal on time axis either left or either right. So if you have a continuous time signal, then the time shift is simply t minus t naught. If you have a discrete time signal, then it is n minus n naught. So the basic reference is the time, which is you have this axis. So the basic reference is the time. So the first thing is that take all this stuff t minus t naught and put it equal to 0. After that just do some simplification and this is t0. Let's say we have two cases here. t0 can be negative, or in other case n0 can be negative. So if it is negative, then you have to move the signal to the left side. So it is shift the signal to the left side, which means that you are advancing the signal if it is positive, t0 is positive, then you shift the signal to the right side, which means that the signal is now delayed. So let's look at an example. Let's say you have this signal which is given like this, and you shift this signal, which means that you have this signal and you shift now by this amount. So t minus t naught is equal to 0 and t is equal to t naught. Now if I consider that t naught is less than 0, which means that t naught is negative, and if t naught is negative, then we move the signal towards the left side. So it is left side. So now the signal is moved to left side by t naught amount. So the point at 0 is now shifted to the t naught point. So it is like this. So now you can see that previously the point which was happening at 0 is now happening before 0 at t naught. So you can say that the signal is advanced, like the signal is starting early. And if this was positive, then the t naught would be on the right side, and you would have said that the signal is now delayed, because previously it was starting at 0. And if it starts with t naught, which is positive, then it would have been delayed. Okay. So the next thing is the time reversal. Time reversal is simply you flip a signal along a time axis. So it simply means that the signal is played backward in time. Mathematically speaking, it is reversing the order of its values. So you have a signal x of t, and you flip this signal, which is x of minus t. You have discrete time signal, which is x of n, and you flip this as x of minus n. Remember, this transformation is with respect to the independent variable t. So all the transformations are applied to the independent variable t. So it is a reflection around t is equal to 0. Let's look at time scaling, which is the third transformation. So time scaling is a process of stretching or compressing a signal along a time axis. So basically this operation alters the speed of the signal. So you have a signal x of t, and the scaling is simply you multiply the independent variable with some parameter which is a. So let's say if a is greater than 1, then the signal is played fastly, which means that now the signal is compressed, because previously the sound that you were able to hear in 1 second is now compressed. You can hear the same sound in less than 1 second. And if a is within the interval 0 to 1, it simply means that the sound is now played slowly, which is like you are stretching the signal. So the scaling is with reference of 1. So you have a of t is equal to 1. So simply it is like the value that you have at the time axis, you divide that value by the variable a. So now let's look at the combination of these three things. We have seen time shift. The second thing was time reversing. And the third thing was time scaling. So if you have more than one transformation at a given time, then the order of doing the operation is very important, because the scaling, which is simply you multiply the time with some variable, and reversal, which is simply you flip the time, are commutative. Commutative simply means that in whatever order you perform these two operations, it doesn't matter, but the shifting is not commutative with respect to the scaling or reversal. So the order for the shifting matters, which simply means that the amount and direction of shift depends on whether you perform it before or after the reversal and scaling. So the time shifting, the amount and the direction of the shift depends on whether you perform the time shifting before or after the reversing or the scaling. So let's fix a rule. The rule that we will follow is we will do shifting as first step. The second step that we will always follow is reversal, and the third step is scaling. To remember it easily, we can use these two keywords. For signals and system, we have SNS. So here we can say that this is SRS. S is for shifting, R is for reversal, and S is for scaling. Now to remember that the shifting or the scaling is the first one or the last one, you can remember this another word, which is HEC, the second letter of all these words. So H is for shifting and C is for scaling. So these two words will help you to remember the fixing rule. So if you have a signal x of t and you have this transformation which is alpha of t minus beta, so the first thing is you will do the shifting first, and the second thing is you have no reversal of time but you have a scaling. So the second thing is scaling. And remember, if alpha is greater than 0, signal is played fastly, as I already told you, and if alpha is within 0 to 1, then the signal is slowed. And if the beta is greater than 0, the signal moves to right, which is delayed, and if beta is less than 0, the signal moves to the left, which is advanced. So let's look at an example. Let's say you are given this signal. And so this is the time axis, and this is x of t signal. At 1 it has a value of 1, at 2 it is 0, and then at all other points it is 0. So you are said to find x of t plus 1, then x of minus t plus 1, x of 3 by 2t, and then you have x of 3 by 2t plus 1. So let's look at the first part, which is x of t plus 1. So here you simply have the shifting, no other operation. And for the shifting we said that it is t plus 1 is equal to 0. So t is equal to minus 1, and the minus sign is saying that you have to shift to the left side by 1. So let's draw the shifted version. Okay, let's draw the shifted version, which simply means that the point which was at 0 is now shifted to minus 1, and the point which was at 1 is now shifted to 0. So we have this signal. So now this is 0, this is 1, this is minus 1, and this is 1. So this is x of t plus 1. So this is it. Then the next thing is x of minus t plus 1. So here you have two operations. One is shifting, another one is reversal. So if you remember, the order was SRS and HEC. So here we don't have the scaling, we have the shifting, which is the first, and second one is the reversal. So you have to shift by the order of 1. So you have a signal x of t. So the first thing is you shift by the order of 1, t plus 1, and then you flip the time variable, which is t, so minus t plus 1. So you will end up with x of minus t plus 1. So if you shift by plus 1, if you remember, this is the first part that we have already done. So we have this signal here. So what we have to do, we have to actually flip this signal, and if we flip this signal, then it is simply this signal. It is simply this signal. So this is minus 1, this is 1, 0, this is 1, and this is the time axis, and this is minus t plus 1. So the next is x of 3 by 2t. So here we have a scaling by the factor of 3 by 2, which is actually a. So the first thing is you simply draw the signal. So the original signal is given by this stuff, in which this is the time axis, this is 1 and this is 2, this is 1, and this is x of t, this is 0, and here you have 0. So now the time scaling is simply you divide every number here by a, and if you divide every number here by a, which is actually 3 by 2, so the number which you will get is even less than the number which was already there, because you have a fractional number here. So in actual, the signal is compressed, and we can see that the signal will now be something like this. And these values are, this was 1 over 3 by 2, so is 2 over 3, and this was actually 2 over 3 by 2, 4 over 2, and then it continues. So this is 1, so this is x of 3 by 2t. Okay, so this is 4 by 3. Okay, so now if we move to the last part, which is x of 3 by 2t plus 1, here you have a scaling and the shifting. So if you remember the order, which was this, so you have a shifting which is first in order, and then you have reversing, and you don't have the reversing here, but you have the scaling. So the second thing is scaling. So I simply do the shifting first, which is x of t. You shift by x of t plus 1, which means that you shift this signal to left by 1, which is essentially the first part of this question, and then you scale the independent variable by 3 by 2 plus 1. So if you look at the first part of this signal, we already know that this is, let's draw both signals here. We already know that this is the first part, which is x of t plus 1, in which you have shifted the signal to the left side by 1. And now you squeeze this signal, which is essentially you squeeze this signal. So the new time axes are minus 2 by 3 and plus 2 by 3. This is 1 and this is minus 1. Okay, this is 0. This is 1 and now this is 3 by 2 t plus 1. So this is all about the transformations, which will be helpful in defining few signals and also to analyze a few systems in the coming lectures. Thank you very much for now and see you in the next video.